lesson 8.2, we're going to talk about some very specific kind of linear equations, and those are horizontal and vertical lines. Now this messes with your head a little bit because we know that the x-axis is similar to when we read left to right first, so the x we go first, and y, after we get done with a line in a book, we go down to the next line, we go up to the next page. So the y-axis is the vertical axis. However, when we are graphing an equation that is just simply y equals 3, that means that y is always going to be 3. So when I go on the y-axis, it's always going to be 3. There it is, says 3 there. We could also say that, make sure I have my, this is also a y equals 3. Happens to be when x is 3, then y is 3. But we could have a y equals 3 here. I think you're getting the point here. If y equals 3 and we connect those points, we have a horizontal line. So when we only have an output that y is 3, we're going to have a horizontal line. In the same regards, if x is going to equal -2, that means I'm always going to go to the left 2. So it doesn't matter where I'm going up and down, I'm always going to go to the left 2 or -2. So when I have a statement that is simply x equals a value, that is going to create a vertical line. So when you have an equation that is y equals a value, that makes a horizontal line. X equals a value makes a vertical line. So, talking about equations and functions. In example 3 and 4, the vertical line test showed that y equals 2x minus 1 and y equals 3 are functions, while x equals -2 is not a function unless its graph is a vertical line. Oh, let's see. An equation that is solved for y is in function form. You may find it helpful to write an equation in a function form before graphing it. So, if you look at our first equation, 3x plus y equals 7, that's not in function form. That's an equation form, but we're going to change it to a function form. Again, function means it's going to be work, okay? So we're going to say that if you talk about input-output, when I substitute a value in for x, the work that results gives me y. So that's why we can do it in an input-output chart, that we will give different x's to find what the output, the x's are the input, what the output might be for our y. This is a function form. So if we're going to do this next equation, we have x plus 2y equals 6. We want to write that in function form, and we want to do that whenever we see the word graph. Whenever we see the word graph, we want to make sure that the equation is written in function form. So, to have it in function form, we need to solve for a single y. So we're going to first get rid of our x. So I'm going to take x off of both sides. Now I'm going to tell you something simple to do here that will help you later when I define some more of these terms. So now I have 2y equals, I do not have like terms here. I'm going to write my variable first. I'm going to write my -x, and then I have a +6. I would suggest writing it in this order. It will help you when we get into some more technical terms later in this chapter. So now again, I need to solve for a single y. This is what we've been doing with our algebra. So I'm going to divide both sides by 2. 2 over 2 equals 1. So I have y equals, now I have -x over 2. I also have 6 over 2. -x over 2 could be written as -1/2. Whoops. Let me rewrite my half here. 1/2 x. And 6 divided by 2 is going to be a +3. Remember, this applies to both of the terms in that equation. So now I have it written in function form. Now, because I have a fraction as a coefficient to my x, I'm going to put in, first of all, I'm going to start out with these. This is from the book and I've just copied it, but I'm going to put in these values. Because I want to get rid of, we don't like to work with fractions, even though we just practiced it before the break, we're going to put in numbers that will get rid of the fraction. So if I substitute x as -2, -1/2 times -2 is going to give me a +1. 1 plus 3 gives me 4. 0 is always your favorite. That's your easiest one to substitute in because when you put that in with that coefficient, you're always going to end up with 0. So 0 plus 3 gives me 3. And now if I substitute in my +2, I'm right here, -1/2 times 2 would give me a -1. -1 plus 3 would give me 2. Now they've also given you 2 other inputs, -4 and 4, again because that will get rid of our fraction coefficient. So if I put a -4 in there, -1/2 times a -4 gives me a +2. 2 plus 3 gives me 5. -1/2 times a +4 gives me a -2. And then 2 plus 3 gives me 1. So here's where I'm getting my input-output charts. I'm inputting into the equation, that's my x, and my output becomes what the answer is, which is my y. Now, I copied my input-output chart again. Now all I need to do is graph it. So let's go ahead. -4, 5. I'm going to come over to the left, again, left, right first, and then I'm going to go up because it's positive to 5. -2, 4. Put me right there. 0, I'm not going to go left or right at all, but I am going to go up to 3. 2, +2, so I go to the right. I also go up 2, both positives, and over 4, up 1. And again, you've now graphed a linear equation. You're going to be able to draw a line through those points. And you will have a straight line going through those points because it is a linear equation. And that concludes lesson 8.2.